Hello everyone, today we'll be doing question 16 on the 2024 AMC 10A. So this question is like those type of questions that look really scary at first, like what the heck is this? Like, look at all these squares. It's like, and look at these answer choices. There's no intuitive way to approach this, right? Well, not exactly. So the key to solving these questions is to keep a cool mind and see what you notice. So, first of all, let's read the question. All of the rectangles in the figure below, which is drawn to scale, so technically, if you know how to compute these or estimate these, you could just use a ruler, are similar to the enclosing rectangle. So they're all similar to this big rectangle, which means they're all similar to each other. Each number represents the area of the rectangle. What is length AB? So, first of all, what you need to know is that, oops, that is not what I was intending to do. I believe the draw function is here. Yeah, there it is. So, first of all, if we have two shapes that are similar, I'm going to draw some new ones. So let's say, oh, that's a terrible shape. If we have a square, let's pretend this is a square, its area is 1. We have another square, its area is 4. What is the ratio between its sides? Well, we know that the length is simply square root of the area, so it'd be 1 and 2. And this holds true for any 2D shape. So the ratio between their lengths is equal to the ratio of the square roots of their areas. So in this case, we have 1 over 2 equals square root of 1 square root of 4. And this goes for any 2D shape, from the radius of a circle to the side of a hexagon, or I don't know, to the circumference of this shape and this shape. Let's just put 2 and 10, they are similar. As long as they are similar, which in this case all of these are, and so are these squares, so are these in our example, the length will always be this. The ratio of the length will always be the same as the ratio of the square roots of the areas. How does this help us? Well, let's see where we can begin on this question. So, when I was solving this question, my first thought was to consider this rectangle with area 1, the one right over here. So what I did was that I set the shorter length to x and the longer length to y. How does this help us? Well, remembering what we did just now about the ratios of side length being the same as the ratio of the square roots of the areas, we can write these length AB as a sum of these three lengths, which we can find by using the ratios we discussed earlier. How do we do that? Well, let's take this 49 for example. This is the short length. It corresponds to the x on this small rectangle. 49 square root is 7. So, by what we just did, this length should be 7x. Similarly, since the square root of 25 is 5, this will be 5x. And since the square root of 32 is 4 root 2, right? This will be 4 root 2y. Because notice how this is the longer side of the rectangle. So this would actually be 4 root 2y, not x. So, pardon the bad order I want to write. So usually you will write 4y root 2, but I want to put the variable at the end to just make it a bit clearer. Okay, so now what? Well, now we can simply write, so now we probably would need an equation, right? To relate AB to something equal. What is equal to AB that we can find? Notice how, remember, this is a rectangle. What's equal to this side? The side opposite it. So let's find these four lengths and add them up using the same way. So since it's the same thing, I'm going to speedrun it. So this would be 6x. So make sure you understand how I'm getting these numbers. This will be 4x, right? This is the long length, so we're getting 2 root 2y. Make sure you realize why it's y, because it's the long length, which corresponds to y here. And this would be 3 root 2y. Well, now what? We, of course, set these two as equal. So we have 5 plus 7 is 12. We got 12x plus 4 root 2y, 4 root 2y equals this top length. 6 plus 4 is 10, so 10x plus 5, 2 plus 3 is 5. Oops, that's a terrible plus. 5 root 2y. And we can solve x for y for x. So same thing, it should result in the same thing. We move the 10 to the left, so we get 2x. Move the 4 root 2 to the right, equals square root of 2y. And if we divide the square root of on the right to the left, we obtain, I'm going to use this color, we obtain square root of 2x equals y. Okay, but this doesn't help us find a b, because we need to find an exact value. We don't know what x and y are yet, or do we? So remember that x and y are defined as the sides of the rectangle with area 1. What does this mean? Of course, it means that xy is simply 1, right? So I am going to start writing it here. I'm going to change the color. So I will start here. We have xy equals 1. We know y equals square root 2x, so we can simply write this as x times x root 2 equals 1, or x squared root 2 equals 1. Therefore, x equals, so I'm skipping a step here, but hopefully you get how I get here, 4th root of 2, because you divide square root of 2 down there, and then you take square root. And because of this, since xy equals 1, we know y equals root 4, 2. So right now, of course, you can plug it in and find the exact value of AB, but I'm going to do like a little bit of cheating here. Since we know that there's a 4th root, we can kind of assume that the answer of AB will have a 4th root, right? Because we already have like a 4th root here, a 4th root here. It should have a 4th root. So that's why, looking at the answers, only D has a 4th root. So the answer would simply be D. And if you check it by plugging it in, you will realize that it results in the same thing. And that is our answer. So remember, these questions, they look really difficult, but if you find the key to the answer, it becomes really, really simple. I mean, it's still a bunch of calculations, but much simpler than you would think. Thanks for watching Animated Minds. I'll see you in the next one.